Hello, welcome to a video on sections 2.4 and 2.5, and this is actually a fresh video for 2012, so you got a fresh homegrown video for 2012. So fortunately I found the time to make a new video for you guys instead of giving you one from last year. So for section 2.4, the title of that section is Write Equations of Lines. And I would say that this is probably one of the most important sections of chapter 2, simply because it plays a crucial role in pre-calculus, and believe it or not, use this concept often in calculus. So I want to make sure you guys are getting this really good, and we'll do some practice after you watch this video. So I'm going to do 5 examples. But before I do the 5 examples, some things you need to know. Slope-intercept form is the following: y equals mx plus b, where m is the slope and b is the y-intercept. Another form that's good to know is point-slope form. And that looks like this. Where m is still the slope, but then x1 comma y1 will be a given point. So now we'll do some examples. So in each example, the instructions will be the same. So for number 1 through 5, write an equation of the line in slope-intercept form using the given information. So here will be the given information. So that's number 1. Number 2, number 3, and number 4, and finally number 5. Okay, so let's go to number 1. So very simple. You're asked to write equation slope-intercept form. So y equals mx plus b. clearly that's m, and clearly that's b, because remember, m represents the slope and b represents the y-intercept. So the equation is just going to be y equals 2x minus 4. That's an easy one. Number 2 requires a bit more work. Again, we're asked to write an equation in slope-intercept form. So that's m, but b, we do not know. So here's what you can do. You can actually use the point slope formula to help you out. Y minus y1 equals m times x minus x1. So I'll say y minus 3 equals negative half times x minus negative 1. If I work it out, y minus 3 equals negative half x, and it actually should come out to being minus half, because minus negative 1 is positive 1, and you shoot negative half becomes negative half. So when I get y all by itself, I get negative half x plus 5 halves, because 3 plus negative half will be 5 halves. Number 3 requires even a bit more work, because we don't know the slope, nor would you know the y-intercept right away. But the slope, remember, is a change of y over a change of x. So you want to subtract the y values and subtract the x values. So if we do 8 minus 0 over negative 4 minus 2, I get 8 over negative 6, which is negative 4/3. And then I can use either 2, 0 or negative 4, 8 as x1 comma y1. So we could say, let's say we use 2, 0. Doesn't really matter, but that's just easier to use. Y minus 0 equals negative 4/3 x minus 2. So y equals negative 4/3 x plus 8/3. And then lastly for, well not lastly, sorry, there's 2 more. For number 4, now if you're parallel, you want the same slope. Now again, we don't know what m is or b is right off the bat. But if I rewrite the equation I'm parallel to, you can see that the slope is negative 2/3. And we're going to pass through this, which we can call x1 and y1. So y minus negative 1 equals negative 2/3 x minus 1. Y plus 1 equals negative 2/3 x plus 2/3. Y equals negative 2/3 x minus 1/3. And by the way, you can always check your work by just plugging in the points and see if it works out. Okay, for number 5. Perpendicular, remember that means negative reciprocal slope. So again, we have to rewrite so we can get the slope for the line that we're perpendicular to. So y equals 3/4 x plus 2. However, we're going to use negative 4/3. Again, that's going to be x1 and y1. So y minus 3 equals negative 4/3 x minus negative 2. So you get y equals negative 4/3 x. That would be, because that becomes plus, so it'll be minus 8/3. Add 3 to both sides, you should get that. So it's a very mechanical process for all these problems. And obviously we're going to do some practice with this in class after you're done watching the video. But if you go over 2.5, it's really not that bad of a concept. Let me change colors up. So section 2.5 is labeled or titled Direct Variation. So all that we're doing here is using this formula. So this is the formula for direct variation, where k is the constant of variation. So what that means is that k equals y over x. So y and x are always in a constant ratio. If you think about it, y equals kx is like a line, with k as a slope and 0, 0 as the y-intercept. And that's because you don't see anything added or subtracted to the equation. We'll just do one example, and then you can do some classwork afterwards. So, we'll start with example number 6. If x and y vary directly, write an equation that relates x and y if x equals 5 when y equals 2. Then find what y equals when x equals 10. So very easy. So y equals kx. You want to plug in 2 for y and 5 for x. So k is going to equal 2/5. So your equation will then be y equals 2/5 x. Then, when x equals 10, we want to know what y equals. And you see how it just doubles. That should happen because that's why we call it direct variation. Whatever we do to x, if we double it, then y doubles. If we triple x, y triples. If we quadruple x, y quadruples. If we divide x by 2, y gets divided by 2. So we'll leave it at that because obviously you're going to do a lot more practice with direct variation in class today. And it looks like we're all set. Okay, hope you enjoyed the video, and of course I'll see you when I see you. Goodbye.